In the last video we were looking at the graphs of cos of x and sine of x. I'm calling this function here f of x and this one here g of x. We saw that if we change the value of b, we change the period of both of these functions. The period is given by 2 pi over b. So if we increase the denominator of a fraction, we decrease the fraction. So increasing b will decrease the period. As you can see here, the period is the smallest interval over which these functions repeat themselves. And if we go the other way, if we decrease b, if we're decreasing the denominator of a fraction, we are increasing the fraction. So we are increasing the period. So as we head towards 0 here, the period is heading towards infinity. And we can make b negative. Well, a negative value of b has no effect on the cos function. The cos of minus 1x is the same as the cos of 1x. It's for negative angles. However, the sine of minus 1x is minus sine x. So if we make b negative, if we go from sine 1x to sine minus 1x, the sine function is made negative, so the sine function is reflected through the x-axis. So look at this again for b equals plus 1. Here's the sine function. Now if I make b minus 1, you'll see the sine graph being reflected through the x-axis, but the cos function stays the same. And I'll make b go back to plus 1 again. Now the range of sine bx and cos bx is from minus 1 to plus 1. It doesn't matter what b is. So I've set a to be 1 in this case, and you can see the range is always from minus 1 to plus 1. We haven't changed that. So the sine function always lies between minus 1 and plus 1. The same is true for cos bx. It lies between minus 1 and plus 1. However, if we multiply all of this by a, we will have changed the range. So we can change the value of a here, and we know what happens. If we increase a, we increase the range. If we decrease a, we decrease the range. So I've multiplied both of these inequalities by a. Now a, I'm assuming, is a positive number. So when we multiply by a, we'll get this. A times minus 1 is minus a. Then we'll have a sine bx in here. A times 1 is a. I've done the same for minus 1 less than or equal to cos bx less than or equal to plus 1. So if I increase a here, you can see that the functions run from minus a to plus a. So when a is 3, the range is from minus 3 to plus 3. Actually, even if I make a negative, these are still true. You know, if you imagine multiplying through by a negative number, it reverses the direction of the inequalities. But then we can just turn the whole thing around. You know, we'll have plus a here greater than or equal to a sine bx greater than or equal to a, or e minus a. You know, and then we can reverse it. Now let's look at the effect of adding d in. So d is any number that we just add to this. So basically we take the y values of points on these curves and we just add on this number d. Now d could be positive or negative. If d is positive, then we're raising the graphs up by that amount. So for example, if d is 2, we're adding 2 onto the y values of both graphs. And you can see what that has done to the range. So we have to add 2 onto the lowest value and 2 onto the highest value. So I'll make a, I'll go make a 1 again. Bring d back to 0. So this is when a is 1, the range is from minus 1 to plus 1. So if I increase d, say to 2, now the range has gone from minus 1 plus 2, which is plus 1, to 1 plus 2, which is 3. So the range is from 1 to 3. So we can imagine adding d onto both of these inequalities. So we'd have minus a plus d is less than or equal to d plus a sine bx less than or equal to d plus a. So changing d affects the range. It has no effect on the period. The period is only affected by b. So adding d onto the cos and sine functions, all it does is raise the functions up or down. D is positive, it's raised up. If d is negative, the graph is lowered. That's true if you add a number, a constant, onto any function, of course. We don't have to be talking about trigonometric functions.